Hi Year 9 and welcome to the first of 5 videos for the topic of surface area. In this first video we're going to review the area of plane shapes. Now recall that the area of a shape is the measure of the space inside the shape, and this shape here has an area of 8 units squared. But the units we typically use for area are centimetres squared, metres squared, hectare and kilometres squared. And this little 2 that's above these measurements, that means 2 dimensions. When we convert units of area, we have to do the conversion twice, once for each dimension. Now, I mentioned before that the 2 above the centimetres squared reminds us that it's 2-dimensional. I could rewrite this as centimetres times centimetres. You should know that from your index laws. Have a look at this graphic. This is a representation of a centimetre squared. We've got 1 centimetre by 1 centimetre. Can you see that it is equivalent to more than 10 millimetres squared? I mean, there's 10 millimetres squared just on this top row. So we have to do the conversion for this dimension, 1 centimetre equals 10 millimetres, and we have to do it for this one. 1 centimetre equals 10 millimetres. So if we want to convert 1 centimetre squared to millimetres squared, we do 1 times 10 times 10, which is 100 millimetres squared. Or we could be sneaky and do it in index form, 1 times 10 squared. Let's look at a couple of examples. Convert 2.5 metres squared to centimetres squared. All right, first thing we've got to figure out is whether we multiply or divide. And that's probably the hardest bit, to be honest. And the way to do it is to think about what a metre squared looks like in comparison to a centimetre squared. A metre squared is much bigger than a centimetre squared. So if I'm going from bigger things to smaller things, I want more of them. The way in maths to get more things is to multiply. So I want to times by the conversion factor, and I want to times by the conversion factor twice because they're area units. All right, how many centimetres are there in a metre? There are 100. So I'm going to do 2.5 times 100, that's my conversion, squared, which gives me 25,000 centimetres squared. Here's one more, 14,000 millimetres squared to centimetres squared. Let's try and figure out whether we are multiplying or dividing. What does a millimetre squared look like? It looks like a dot, doesn't it? Tiny, tiny thing. And we're going to a centimetre squared, which is a little bit bigger. So we're going from tiny things to bigger things. We want less of them. We need to divide. So I'm going to divide by the conversion. How many millimetres in a centimetre? There are 10. So I'm going to do 14,000 divided by 10 squared because they're area units, and that gives me 140 millimetres squared. Now the hectare is a special case, and it's used for measuring land sizes. And there you can see a picture of my farm in Australia, which I haven't seen for a while. And it's about 27 hectares. Now, 1 hectare, and this is its symbol, HA, is the same as 10,000 square metres. Now, can you see something curious here? Something that's different to the previous conversions I showed you. This one doesn't have a little 2 up the top. Okay, it is just a name given to a certain number of metres squared, which happens to be 10,000. So if we do the conversions, we don't have to do them twice. Let's have a look at one. Let's convert 4.1 hectares to metres squared. Well, 1 hectare is 10,000 metres squared. Can you see how I'm going to just naturally turn it into metres squared? So all I need to do is 4.1 lots of 10,000. So our answer is 41,000 metres squared. Okay, let's move on to our area formulae. We'll start with rectangle. The formula for the area of a rectangle is length times breadth. And another word for breadth is width. Now in primary school you learnt to count these squares, and you would have worked out that this has an area of 8 centimetres squared. But then you very quickly learnt that multiplication was quicker. 4 times 2 gives us 8 centimetres squared. A triangle is half of a rectangle around it, so the formula is a half times the base times the height. So in this case our base is 4, our height is 2, a half times 4 times 2 is 4 centimetres squared. Now, did you notice something curious there? I changed the words. In a rectangle, we do length times breadth. In a triangle, we do base times height. And the reason is the triangle can take different forms, and length and breadth aren't the right words. Now, when we talk about height in an area formula, we're almost always referring to the perpendicular height. That means it has to be at right angles to the base measurement. So here's 3 different orientations of triangles. And in each case, we've got a base of 4 and a perpendicular height of 5. So what does that mean? It means each of those triangles has got the same area. Half times the base times the height. Half of 4 is 2. 2 times 5 is 10 centimeters squared. A parallelogram is an oblique rectangle. That means it's pushed over. It's not at right angles. It has the same formula, however, as the rectangle. But again, I've changed the words. It's area equals base times height. Have a look at this picture. Here we've got our rectangle, length times breadth. Here we've got our parallelogram, base times perpendicular height. Again, it has the same area. 4 times 2 is 8 centimeters squared. Okay, let's move on to the area of a trapezium. Now the formula is height, perpendicular height, divided by 2 multiplied by a plus b in brackets, which are the parallel sides. Now it's really easy to see where this formula came from. Suppose I take the midpoint of both sides and I colour in this little triangle area down here like that. Now picking it up and spinning it around up the top like that, I have got a rectangle. The formula for the area of a rectangle is length times breadth. But this is not 8 here. Okay, 8 is all the way to the end here. So what's this measurement between here and here? It's actually the average of the 2 sides, the 8 and the 6. How do you work out the average? Add them up, divide by how many there are. So 6 plus 8 divided by 2. Have a look at the formula. Here's our parallel sides divided by 2. So this is just the perpendicular height multiplied by the average of the 2 parallel sides. Let's get rid of all that mess. Back to our trapezium. Put it into the formula. There's our height. The 6 and the 8 go in here. And then 6 and 8 is 14. 4 divided by 2 is 2. 2 times 14 is 28 centimeters squared. Now be careful of shapes in different orientations. So have a look at this trapezium. What's the height of it? Can you see that that's 5? I mean, it's a funny trapezium anyway because it's got right angles here. It doesn't sort of slant out. Here's our parallel sides here, the 11 and the 7. Once you know what's what, it's pretty easy. Okay, there's our perpendicular height over 2 and then 11 plus 7. 11 and 7 is 18. A half of 18 is 9. 5 nines, 45 meters squared. Okay, rhombus and kite. This is our last area formula for quadrilaterals. And they have the same formula, so that's lucky. And it is a half xy, and xy is referring to the lengths of the diagonals. Now, I've made a big point in this video about how measurements in area formulas are almost always at right angles, and they are here too. Because one of the properties of the rhombus and the kite is that the diagonals meet at right angles. So we've got one diagonal being 4 centimeters long, the other is 10 centimeters long. Let's substitute into the formula. Order is not important because we're multiplying. A half of 4 is 2. 2 times 10 is 20. 20 centimeters squared. Which brings us nicely to the area of a circle. And I'm sure you're familiar with the formula, which is pi r squared. And r is the radius. So if we have a look at this example here, we have a circle with radius 4 centimeters. All I do is substitute the 4 in where the r was. And don't forget that there's a times in between the pi and the r. I have to put it on the calculator. So pi times 4 squared gives me 50.3 centimeters squared. Now I usually get my students to give their answer to 1 decimal place. Now one of the tricky things we can do with an area of a circle is give you the diameter instead of the radius. And you can see that in this example here. But the diameter is twice the radius. So we've just got one extra step. We have to figure out what the radius is first. So I do half of 10. Half of 10 is 5. into the formula, so it goes in here where R is, into the calculator, gives me 78.5 meters squared. We can also find the area of semicircles and quadrants. All we have to do in each case is work out the proportion of the circle that we have. So with a semicircle, we have half of a circle, don't we? So we just take our formula, pi r squared, and we divide by 2. Or we could do a half times pi r squared. So we're going to do a half times pi times, oh, where did this 2 come from? Oh, look at that, sneaky. We have the diameter here, not the radius. So to find the radius, we have to do half of the diameter, which is 2. Half times pi times 2 squared, which is 6.3 centimeters squared. With a quadrant, we have a quarter of a circle. So we're going to do pi r squared divided by 4, or we can do a quarter times pi r squared. This time we do have the radius, so it's a quarter times pi times 3 squared, which is 7.1 meters squared. Now semicircles and quadrants are okay because we know those proportions. But what about other sectors? A sector in a circle is like a piece of pizza. It has a certain angle, like here, and there's the radius of the pizza. Here's the formula to find the area of any sector. So we've got our angle out of 360, so that gives us our proportion of the circle that we want. And this is the formula for the area of a circle. Here's an example. Our angle is 130 degrees. Our radius is 1.2 centimeters. So let's put it into the formula. So this is theta, which is that, out of 360 times pi times r squared. Into the calculator, we get 1.6 centimeters squared. Okay, last bit. We can look at composite shapes. And a composite shape is just got multiple areas. And we can either add areas together, or we can subtract an area from another area. Here's our first example. Find the area of the following shape. So this shape is made up of 2 rectangles, and we can label them area 1 and area 2. Let's have a look at area 1. We have the information we need. We know the length is 14 and we know the breadth is 4. So into the formula, 14 times 4 is 56 centimeters squared. Now let's look at area 2. We don't have enough information. We know the width or the breadth is 6, but we don't know this measurement here. Let's see if we can figure it out. Along the top here we've got 14 centimeters, and then here we've got 5, and here we've got 5. What's this missing measurement here? It has to be 4, doesn't it? So our length is 4 centimeters. Into the formula, 4 times 6 is 24 centimeters squared. We need to add those 2 areas together, and we end up with 80 centimeters squared. Here's our second example. A rectangular garden of dimensions 12 meters by 4 meters has a concrete path of width 0.5 of a meter constructed around it. Calculate the area of the concrete path. All right, so we can see that we have got the garden here, which has got dimensions 12 meters by 4 meters, but we don't actually know the dimensions of this larger rectangle. However, we know that the path has got width 0.5 meters. So if we have a look at this dimension here, we've got 4 meters in the middle, and then half a meter here and half a meter here, and so the width of this larger rectangle is going to be 5 meters. We also know that the concrete path measures 0.5 meters this side and this side. So having a look along this dimension, we've got 12 plus 0.5 plus 0.5, which is 13 meters. All right, we're ready to work out the areas. The area of the large rectangle is 13 times 5, which is 65 meters squared. The area of the small rectangle is 12 by 4, which is 48 meters squared. And if we subtract the small rectangle from the large rectangle, we get the total area of the concrete path, which is 17 meters squared. Okay, let's finish off with one that's just slightly harder. Here we've got a rectangle that's joined to a quadrant. Okay, We're struggling a little bit to find any dimensions here. We know the width or the breadth of the rectangle, but we don't know the length, and we don't know the radius of the quadrant. But we do know that this distance from here to here is 10, which is the radius. So that's 10, which makes this distance along here, which is also a radius, 10 as well. So can you figure this part out here? This must be 25, take away 10, which is 15. Okay, we're ready to go. So area 1 is my rectangle. It is going to be 15 times 10, which is 150 meters squared. And area 2 is going to be this quadrant, which is going to be 1/4 times pi times r squared. Put it in the calculator, I get 78.5 meters squared. And my total area, I have to add those two together, and I get 228.5 meters squared. Okay, you did pretty well if you got through all of that. Our next lesson, we're going to learn about surface area of prisms.